All right, so you want to open up number 1 for today, which is the phase change lesson 2.2. Should take you to the Nearpod. And here we are. So yesterday we thought a lot about the macro scale appearance of phase changes, and in lessons previous to that by looking at those videos. Today we're going to investigate the molecular scale, the teeny tiny little molecules that make up the substance. The question will help us to investigate whether the lake on Titan evaporated or froze. So we're still trying to figure that out. Which of those two things happened, okay? So the question is, what happens to the molecules of a substance when it changes phase? So we focused on the appearance. Now we're focusing on the molecules. When something changes from a liquid to a gas, the molecules that make that substance up are doing a whole lot of things. They're all over the place, and you can't see that. So we're going to focus on those changes on the molecular scale. So we have a new message from Dr. Flores, and if you can't see yours, you can zoom in, but I'll read to you. The student, 2 student chemists, that's you, from Dr. Danella Flores, the lead chemist at the Space Universal Agency. The subject is phase change simulation. You're off to a great start with your investigation of phase changes. Today, you will explore the phase change simulation to further investigate Titan's methane lake mystery at the molecular scale. As you read in the last lesson, Titan and Earth are similar in a few important ways. As molecules behave the same way everywhere in the universe, this simulation will help you to understand phase changes that occur on Titan. I look forward to your next update. So basically she's telling us that by studying the molecular level, it's going to help us to figure out what's happening on Titan, because no matter where the substance is, it behaves the same way. So the phase change simulation will help us learn more about how substances experience phase changes on a molecular scale. We're going to play the video on the next slide to preview some important features of the sim. So we're going to learn how to use the sim. These videos are super important. Otherwise, you go to use the sim and you have no idea what to do.
This is the phase change sim. You'll use it to learn more about how substances experience phase change on the molecular scale. These spheres represent molecules. Let's press play to run the sim to observe the molecules. On the right are 4 different substances labeled from A to D. Each substance has different attraction levels. You can transfer energy into or out of a substance by pressing the plus or minus buttons under energy. This is the temperature bar on the left. Press on a molecule to track it. You can also track 2 molecules at once. You can use these buttons to rotate or bump the container. These buttons can change the orientation or movement of the container. You'll use this tool to observe substances on both macro and molecular scales.
All right, now that we have a little understanding of how to use the sim, let's talk a little bit about what we're doing. So a model is always different from the real thing or the process that it represents. What are some ways this model, the phase change simulation, is different from real molecules of a substance? Can you think of any ways that maybe this simulation is a little bit different than real molecules? I can't hear you. You can see them, right? So we can't see real molecules. If you were able to look at real molecules in a microscope, do you think they'd be all colorful? No, right? Do you think you could pick one molecule and trace it like you could in the sim and follow it all around? Probably not, right? We can't, just by pushing a button, increase the energy of molecules. Okay, so there's many ways that this model is different, but there's also many ways that this model is the same. So before we can investigate more, let's identify the phase each substance is in. So based on what you observe as we tilt the container, what phase does substance A start in? Okay, so based on what we observe, we're going to tilt the container, and then I want you to think about, before we tilt, what phase does this substance start in? Hold on. I gotta get my sim. Go ahead and go to Amplify. I don't have a link for the sim on there for some reason. So you're gonna have to open a new tab, go to Amplify. And remember to quickly get to your sims. You can push the pancakes all the way on the left. And then you just have to scroll down to find the sim that you want. And we are doing phase change. So they're alphabetical, so it's going to be towards the bottom. It should be right by the plate motion sim. Does anyone need help getting to the sim? Yes? Charger? Yeah. All right, so once you're in the sim, go ahead and choose substance A. And your screen should look similar to my screen. So if we go back to the SimNet or the Nearpod, or you could stay at the sim, but the question is, based on what you observe as we tilt the container, what phase does substance A start in? So here is substance A, and if I rotate the container, won't let me. What phase do we think this is? So remember, you had three key concepts, and they're on the backboard. A solid holds its shape. A gas has no visible shape and fills the container. And a liquid flows and can take the shape of the container. So of those three, what do you think these molecules are doing? What state of matter do you think this would be? Give it a shot, Jacob. Well, are they really flowing now? Like, imagine this was water, right? Liquid, and you tilted the liquid. Would it kind of stay in that line? Not really, right? So they're really kind of resisting movement. If I rotate them back, they don't all of a sudden just flow out like a liquid would. So Sierra, what do you think? Not a liquid, a solid. Good. So a solid holds its shape. This block of molecules here is holding its shape. I don't know if I clicked it. What is that? All right, so just leave your sim on your screen for a moment. So the key concept on the next slide will help us to know that substance A likely starts as a solid because it keeps its shape and does not fill the container when it's rotated. So when I rotate it, it doesn't take the shape of that container, okay? It kind of stays in its position. So a solid holds its shape and does not take the shape of its container. Next, we're going to use the sim to identify the phase that substance B and C start in. So B and C. Are they going to be solids, liquids, or gases? To do this, select the substance and then rotate the container to see what happens. So go ahead on your sim and choose B. And then rotate it. Put it back. Choose C. And rotate it. So if you need to see those again, go ahead and try it again. So this was C. And when I rotate it, and this was B. So you're paying attention to those molecules. All right, so we did this, open the phase change sim, use the sim to identify phase, the phase that substance B and C start in. So we just did that. There's the link for our sim finally. All right, so I don't want to go that far. All right, so tell me then what you think B. What state of matter do you think B is? Sierra? A liquid, good. And how come a liquid? Yeah, and when you turn the container, it still fills that shape, right? It takes the shape of the container and it flows, but it doesn't fill the entire container, okay? So if I rotate it, it flows very nicely. Imagine water just kind of flowing, right? And most of it stays all together down here in the bottom. So Rosemary, if I switch to C, what state of matter would that be? A gas, good. And how come? Yeah, it's all over the place. It's taking the shape of the container. It's filling the whole square, okay? So we want to think about our key ideas when you're looking at those. So you should have been able to observe that B likely starts as a liquid since it fills the bottom of the container and it seems to flow rather than like the solid, just kind of slide in one piece. Substance C likely starts as a gas because it fills the container rather than falling to the bottom of it. So therefore, A is a solid, B is a liquid, and C is a gas. And that's not going to change. So throughout the whole unit, whenever we use the sim, A is a solid, B is a liquid, C is a gas. We haven't talked about D yet. So you can go back to your Nearpod for a moment. A user named TitanFan5 has posted a question on the Space Q&A forum. The question is related to the Titan investigation. Several people responded to TitanFan5's question. Their responses are all claims about what happens to molecules when a substance changes phase. Dr. Flores is very busy, and she needs your help evaluating and responding to these three claims made by different forum users. Read the information on the next two slides to learn more. So go ahead and read what their question was. So TitanFan5's question is very similar to our question, right? We are trying to figure out what happens to the molecules of a substance when they change phase. And these are the three claims that were made by three users. Claim 1 says, I think that molecules in a substance disappear and they no longer exist when a substance changes phase. I think this because when a substance goes from a liquid to a gas, I can no longer see it. So the molecules kind of just go away. Claim 2 by Planet Lover says, I think molecules in a substance move differently when a substance changes phase. I think this because when you tilt the container they are in, a liquid, gas, and solid do not move in the same way. And we kind of saw that. Claim 3 says science, claim 3's name is Science is Cool. And their claim is, I think that the molecules in a substance change into a new kind of molecule during a phase change. I think this because a liquid looks different from a solid or a gas. So the molecules possibly change the way that they look since their appearance looks different on the macro scale. In order to evaluate the 3 claims, you're going to use the sim to learn more about what happens at the molecular scale at each phase. So we're going to go to Google Classroom, leave all the tabs you have open, and open up number 2 for today. And on the Nearpod screen here, it says to use the sim to investigate the molecular scale of phase changes. Complete part 1 only. Come back here when you finish part 1. So we're going to go to Google Classroom and open number 2 for today. I clicked too fast. The directions here, use the phase change sim to investigate the molecular scale of phase changes. Stop at the end of part 1 and return to the Nearpod. All right, so part 1. Launch the sim, which we have. Observe different phases in the sim. In the data table below, record your observations about the molecular scale of each phase. Consider how the movement of molecules relates to the macro scale appearance of each phase. So for a gas, the macro scale fills the container and has no visible shape. That's what we saw on the macro scale. So for the molecular scale, we want to use the sim. Where's my sim? Here's my sim. And we want to have it on gas, which is C. Remember, C is the gas. And we want to rotate it, and we want to bump it, and we want to move those molecules all around. And on your document, you're going to describe how those molecules are moving. So can somebody give me a description of how they're moving? Awesome. Bouncing off of each other everywhere. So that's what you would type in the molecular scale box. Okay? And then do the same thing for the liquid and the solid. When you're done, go back to the Nearpod. So for gas, Sky told us, and the key of what she said was that they were everywhere, okay? In a gas, those molecules were everywhere. Was that true of the liquid? Were they everywhere, all of the molecules? They were, right? So for our liquid, if you didn't have this, I think we would describe that, we got to give them a minute to kind of get into place. But I think we would describe that more as the molecules kind of stay at the bottom of the container. They don't fill the entire container. And they still move, right? They're moving, and they're kind of bouncing off of each other and kind of rolling around. So they're flowing, but they're not all over the place, okay? And then for our solid, they become even more rigid. So in that one, you would describe it more as them remaining in place, okay? They are moving back and forth, but they're very rigid. They're resisting that movement of filling the container. So you should have all 3 of those filled in. Solid, liquid, gas. Questions? Help? We're good. All right, so moving on. So we just talked about this. The solids stay the solids move in place, the liquids move around each other, and the gases move away from each other and everywhere. You don't have to go back and check as long as you made your corrections as we talked about it, but people at home will want to do that. So read what these forum users thought about the molecular scale based on their macro observations. So the first claim was that the molecules in a substance disappear or no longer exist when a substance changes phase. So compare that to what the solid, the liquid, the gas look like. Did they disappear? 2 says they just move differently. And 3 says that they change into a new kind of molecule. Okay, so those are our 3 claims. Clicker. You'll now use evidence or use the sim to find evidence related to the 3 claims. You'll cause a substance to change phase by adding energy and observing what happens to its molecules. You'll observe how the molecules begin to move differently. You can select 1 or 2 molecules to track and closely monitor their behavior. So you can see, are the molecules disappearing? Are they moving differently? Or are they changing into something new, which are our 3 claims. So we already should have our documents open. We're now going to complete part 2 and use evidence from the sim to consider the claims. So if we go back to our document, we're going to scroll down to part 2. Number 1 is to launch the sim. We have that. Number 2, cause a substance to change phase. Observe what happens to the molecules of that substance when it changes phase. Hint, track 1 or 2 molecules by pressing on them, then observe them. Think about the hands-on investigation that we did, as well as the observations you record in the data table above, and think about which of the claims below is best supported by the evidence you gathered in the lesson. So you're going to do this after you've looked at each of the molecules. So we need to cause a molecule to change phase, and the Nearpod told us that we're going to do that by what? How are we going to make them change phase? We're going to add energy. Thank you, Rosemary, for being with me today. We're going to change them by adding energy. So if you start with a solid, go ahead and start with your solid, and click on 1 or 2 of the molecules. I suggest 2. And then begin to add energy, which is the button over here on the right. And observe how they change. So kind of solid. Oh, I'm starting to turn to a liquid because they're starting to kind of escape. Remember, you're thinking about, are those molecules disappearing? Are they changing into a new molecule? Or are they just changing the way that they move as you add energy? And then if you need to, you can go back the other way. Look at my green one. He's all over the place. It's crazy. Oh, got stuck. If you need to, you can decrease the energy again and watch those molecules. Are they disappearing? Are they changing into something new? Or are they just changing the way that they move? Once you feel like you know the answer to that, then you're going to highlight the claim that you believe to be true. Claim 1, claim 2, claim 3, and turn it in. So whichever one you think is true, just select it. That one is not necessarily true. And highlight. You're just picking one. The highlight tool is right next to the text color. You can even change the color of the text. I don't care, just so I know which one you believe is true. Remember, claim 1 says that the molecules disappear. Claim 2 says they move differently. Claim 3 says they change into something completely new. Turn it in when you're done. And then answer the question on your Nearpod screen. Switch. I'm going to turn that heat down before I melt. So based on what you saw on the sim, what happened to the liquid water molecules when they changed to gas? What did those molecules do differently? So we're referring to the experiment from yesterday. If you didn't do it, basically, or watch the video, there was hot water in that foam cup, and it changed, the liquid water changed to a gas. So you're just explaining how those molecules changed during that process based on what we've learned today. Hit submit when you're done. Just waiting on one more. I don't even know who it is, but whoever it is, if you're not sure, just hit submit. All right, so I like this one. They went from not bouncing all over to bouncing all over and filling the whole container, right? So the liquid molecules kind of flowed in place. They stayed to the bottom of the cup, the bottom of the foam cup, but then when they changed to a gas, they all of a sudden started going all over and filling the entire space available to them. Very good. Not something we could see yesterday. So they move all over the place and bounce off each other and fill the shape of the container. Awesome job. The liquid water molecules evaporated and became a gas. They rose up and stayed on the outside of the cup. So this is what we saw. This is the macro scale. Okay, that's what we saw with our naked eyes. I wanted you to think on the molecular scale about what those molecules were doing. So the molecules in the liquid water were moving kind of in the middle, you know, staying towards the bottom, and then they got crazy and started moving all over the place, up and out of the cup. They were at the bottom and they were not so crazy, but when you change it to a gas, it goes everywhere. Awesome job. The molecules lifted and it started to condensate on the top clear cup. So that's a different process, the condensation. But the molecules did rise because they were a gas, and so they started to fill the whole space instead of being contained to the bottom of the cup. Good job. You guys did a great job today. All right, so go ahead. We are done. Go ahead and get your wipes if you're going to wipe down your desk. Make sure you hand it in today's assignment.